Isotopes. We need to use a symbol to show the isotopes. Okay, if I'm talking about carbon and I want to know about an isotope, I need to be able to identify the difference in the carbon isotopes. So we use a symbol system like this. First, we have our X, which represents our atom's symbol. Think of it like algebra. X always represents something, so X is whichever element you want, that's your symbol there. Then the symbol on top, on the left, this is where you put your mass number. It's going to be a whole number because it's the number of protons plus the number of neutrons. The number on bottom is your atomic number, also known as the number of protons. Now, a simple way of remembering the fact that it is written like this is because if I take the top number and I subtract the bottom number, if I take my mass and I subtract my number of protons, I get my number of neutrons. A symbol for neutrons is N with a 0 on top because it has a 0 charge. So you can just write out neutrons if you want. But mass minus my number of protons gives me my number of neutrons. So think of it like a simple subtraction problem. So for example, over here if I have 12 minus 6, that gives me 6 neutrons. Isotopes are only different because of different numbers of neutrons, so we write them in a way that's easy to identify the number of neutrons. So if I was to write it for hydrogen, hydrogen has the symbol H. It asks for the most common isotope, so if I look at the periodic table, the mass of hydrogen is 1.008. So I round that to a whole number and I get a mass of 1 on top. The atomic number of hydrogen is 1, so I put a 1 on bottom. If I wanted to know the number of neutrons, I would subtract this, and 1 minus 1 is 0. The most common isotope of hydrogen does not have any neutrons. It's just a proton in the nucleus. So for bromine, this time bromine has a number beside it. This is another way of identifying an isotope. We write the element, and then we put its mass beside it. Now if you look at your periodic table, the average mass of bromine is 79.9. So the most common isotope of bromine has a mass of 80. This bromine has a mass of 82. That's how we know it's an isotope. It's a different mass from the most common. So to write this out, I put the symbol of bromine, Br, the mass on top, 82, and the atomic number on bottom, 35. So if it asks for the number of protons, that is your atomic number, so that is 35. To find your number of neutrons, subtract 82 minus 35, 47. So to fill in this table, I'll do one of them with you. You use whatever information is given on the line to find everything else. So I'll do the third one with you. I was given number of protons and number of neutrons. Well, from the number of protons, I can get a lot of information. So if my number of protons is 1, then my atomic number is 1. And my number of electrons is 1. That didn't say it had a charge or anything, it's just neutral. So protons and electrons are equal. And in my isotope symbol, my atomic number goes on bottom, so I'll put a 1 on bottom. All of those are the same. Now, because I know my number of protons, I know what element this is. If it has 1 proton, that means it is the element hydrogen. So I'll put the symbol for hydrogen, and I'll put the name. Hydrogen. So the only thing that's missing here is the mass. Well, my number of protons plus my number of neutrons gives me my mass number, 3. The mass number goes on top, 3. And it's also written beside the element name, hydrogen, 3. So you fill in the table based off of the given information. So on the side, we're about to start calculating average atomic mass. And this becomes a very difficult thing for students because they think in the way they've always done average before. If I was to average carbon-12 and carbon-13, you would think, okay, 12 plus 13 divided by 2, which gives me 12.5. Oops. But if you look at your periodic table, the mass is actually 12.01. The average mass comes out to 12.01, which is significantly different than 12.5. What this means is we calculate the mass, the average mass, differently than just add them all up, divide by the number. Okay? The reason is, if we look down here at our percents, carbon-12, it makes up 98.93% of all carbon in the universe. Carbon-13 is only 1.07%. So if we use the average as 12.5, that's really disingenuous. The likelihood of you finding a carbon-13 is slim to none. So the average mass should take that into account, and it does. So what we have for our average atomic mass, it is a weighted average of the masses of each isotopes of an element. A weighted average. And this should be a concept you understand. You have weighted grades. 50% weighted for your major grades and 50% weighted for your daily grades. I've worked at a school before where daily grades was only 20%. 80% of your grades came from major grades, and you would have to calculate your grade based off of that. So it's the same concept here. We want to take in this percent abundance into account. So abundance is how much of something there is, right? How often do you see it? Percent abundance. Of the total amount possible, what percent is present of each? So if we take this into account into our equation, our average atomic mass is the percent of isotope 1 times the mass of isotope 1 plus the percent of isotope 2 times the mass of isotope 2. Which if I wanted to write this in a simpler way to memorize, we'd put average atomic mass equals percent 1 times mass 1. Plus percent 2 times mass 2. And notice it has a dot, dot, dot. That's because depending on however many isotopes you have, you continue. If there's 8 isotopes, then you got to do percent 3 times mass 3 plus percent 4 times mass 4 plus percent 5 times mass 5. Continue for however many isotopes there are. Some elements have 0 isotopes. Some have 8. Depends on the element. Depends on how many neutrons can relate to those protons to hold that nucleus together. So for carbon, I have your example here. If carbon-12 makes up 98.93%, then I plug that into my equation as percent 1. Now remember, when you plug a percent in, you got to put it in decimal form, which means you move the decimal 2 times to the left, going from the percent to the decimal. This is the most common mistake I see. Either A, they don't move the decimal, or B, they don't move it correctly. So notice for my percent for carbon-13 is 1.07, so that's 0.0107. It is not 0.107. You need to move the decimal place twice. Okay. So you plug them in. Percent 1 times mass 1 plus percent 2 times mass 2. If you had more isotopes, continue. Plus percent 3 times mass 3. Make sure you put that percent as a decimal, and that's all you need to do. You just need to know this equation and be able to plug in the information. So let's look at the next page. Your homework are just these 5 problems. This first problem does not ask for you to calculate anything. It just wants you to think it through. Argon has 3 naturally occurring isotopes, argon 36, 38, and 40. If you look at the reported atomic mass, meaning the one on the periodic table, and you compare that to these atomic masses, you should be able to figure out which is the most abundant. So if you look at your periodic table, the average atomic mass of argon is 39.95. So based off of that, you should be able to figure out what is your most abundant isotope. If I calculate the average based off abundance, and my average comes pretty much to 40, argon's going to be my most abundant. Now you need to be able to explain that. For the other 4 problems, you need to be able to calculate that average atomic mass. You can check your answer in the back of the book. Make sure you show your work. You get 0 credit if no work shown.